Wait, oh my god, I wasn't using a mic the whole time? Wow, I feel really dumb right now. Oops. Oops. That's pretty funny. Okay, so the dist. Yeah, okay, but this is not telling me the because like what this should really represent is the distance between vertices, right? I want to be screwing around with that. So how do I know the distance between vertices? Cause like yeah, cause like I don't want like an insane amount of overdraw. I want like a little bit of overdraw, but not an insane amount. I think so. I think it's kind of like, well, okay. So the equation that I do in the terrain mesh is I use a sine h, right? I use a sine h. Or rather, I use sine h. So yeah, originally the distance between them all is, let's see. If I look at this guy, sparse vertices. Okay, so the scale dense radii x radii, x bound. Yeah, I mean, this is all really complicated math, I think. But yeah, fundamentally, the fundamental thing that I need to be operating on is the distance between vertices. Now, now what I could try, or yeah, I guess like, so yeah, the distance between vertices um, is not like the same. It's not uniform, right? Which like yeah, duh. But it is like we can it is like approximately uniform, right? Like it's okay to think about it. Sorry, not uniform, but like dependent on the vertex itself. Right? The one that's closer to the origin is not going to be, at least it shouldn't be so much closer to the origin than the further out one along that same line is further out. So yeah, I guess what it comes down to, right, is yeah, we can ignore this. This is the important part. Okay, so what I need to do is take this sparse vertices, or yeah, if I have two vertices, right, and I want to know the distance between any two vertices. Then it's going to be x squared plus y squared, the square root of that, multiplied by s. So s times the... Okay, so it's going to be the sine h of that, and then divided by s times x squared plus y squared, and then that's going to be times the vector xy. So, yeah, okay. And so if I want to find the distance between that and another vertex, well, specifically I want to know the distance between that and a vertex which is just x rad plus... No. Wait, hold on. What? Yeah, specifically I want to know... Oh, lattice scale factor. Right. So if I add 1, I want to know the dist between, like, a vertex x squared plus y squared oh no, that should be x plus 1, y plus 1, x plus 1, y plus 1. Yeah, okay, so I guess yeah. What is it like just along an axis? Yeah, because like the important value is okay, so if I open up like Desmos or something, right? So I'm looking for, let's say S is, I don't know. What do I have S set to in the code? The scale. .15. Why not? Okay, so S is 0.15. So we have sine h of sx divided by sx That's so interesting. Yeah. For some reason I didn't realize that. Okay, times x. Okay, so that's how that's how x gets transformed, right? It's by this guy. Okay, so now if let's call this f of x. And so that's our transform. Now what I want to know is the distance between f of x and f of x plus 1. And then f of x... Oh, no, this should be f of x plus 1. Oh, no, yeah, abs. Yeah, it should have the absolute value. f of x minus, and then x minus 1. Yeah, okay. It's similar, right? That's what I expect. Like, obviously it diverges, but it's similar. Okay, so what is this? I guess mathematically speaking, Gleb. Ignore me. Wait, am I still streaming at the right output? Yeah, okay. 15,000, yeah. So, I guess, what is this? Sine H S minus sine H S of x plus s divided by... Oh, wait. Yeah, actually, wait. I can't just ignore the x, can I? No, I can't. S, x plus 1, x plus 1. Oh, wait, yeah, I can. Yeah, okay. So it becomes sine h s of x minus sine h s of x plus s all over s. Are there any, like, sine h formulas or whatever? Sine h addition formula for why does addition look so weird? Oh, yeah, yeah. It'd be under identities or whatever. Okay. Alright, so that's sine h x plus y. Yeah, but no. I need, like... Oh, wait. Okay, I doubt it's gonna help me at all. but it might simplify something. 2 sine h x... Wait. Okay, so this is... two cosine h. Okay, so this is s of x minus s of x minus s over 2, and then sine h oh wait, no, this is plus. Yeah. Sine h s of x minus s of x minus s over 2. And then that simplifies to minus s over 2. Okay, so that's a constant. That's cool. And then that becomes 2x plus 1. S times 2x plus 1 over 2. So 2 sine h negative s over 2 Gosh, yeah, okay. I don't know if it's actually any faster. I mean, theoretically, I could get rid of one of the hyperbolic trigonometric calculations, but it's like I don't think it makes a huge difference. Well, anyway, so that's the approximate distance between vertices, I think. Oh wait, hold on a second. No. Wait, there's a part of this that I'm forgetting, which is the scale. Which is the lattice scale factor. I forgot about the lattice scale factor, bros. I guess the lattice scale factor is actually relatively constant. Yeah, like I could make that a constant in the So it is a constant. So yeah, hold on a second. So the actual function is sine h s x over L, and then right, if I go to expand sample, if I go to expand sample, then we divide by s, and then we also divide by x. We also divide by x, but then x is already divided by L. Okay, so the whole thing becomes L sine h sx over L all over sx. And then we multiply by x. Okay. So what does that do to the final thing? Well, yeah, we can get rid of that. But then we have, okay, so it's minus L sine h yeah, because it's going to be x plus 1 over L, so S yeah, okay, it doesn't change much. The only thing I need to worry about is the L, I think. So I need to make a new guy for that. Oh, lattice scale factor. Okay, yeah, I already... Wait, how do I calculate the dense lattice size? Dense radius. How do I know this? Oh. Oh, I calculate it. Oh, okay. Wait. Wait, what? Oh. I'm stupid. Okay. Lattice scale factor. Okay. Oh, I already have lattice scale factor. Oh my gosh. Okay. Wait, did I try doing this at some point? Man, working on this code is like fucking House of Leaves. Like, I don't remember building this. I don't remember building this non-Euclidean room. Um. Yeah. Okay. So the actual calculation for yeah, if it's greater than dense radius, then it's going to actually be the lattice grid. No, wait. Wait, what? Oh, no, it's not lattice grid size, it's lattice. Oh. Yeah. Never mind. Okay. Alright, times sine h. Okay, so scale times scale times dist divided by lattice scale factor minus okay, yeah, I need to do this. Oh, but dist is in world dist. Oh, yeah, okay, wait, hold on a second. There's more to this than I thought. So I need to convert it to the lattice grid size first, and then... No. Fuck me, man. Ah. Okay. So, I need to do... Yeah. Yeah, I forgot that X was not in world space. Okay, so first I need to map it, so I need to retract it, and then I can get, okay, so let sparse lattice space is equal to a sine h dist. Wait, is there no a sine h in WGSL? Surely. Surely you must be joking. Alright, let's just slowly look through. Okay, that's close enough. A sine h. Yeah, okay, there is a sine h. Why was it not? I don't know. What do other people use a sine h for? I feel like it's such a obscure function. Like, genuinely. Like, I don't even know what people would use a hyperbolic sign for. I don't know, man. Expand. We want retract sample. Oh, okay. It's literally the same. So it's... Yeah. And you divide by scale. time scale. Okay, wow. That's really weird how that works. Time scale divided by scale. I just realized that, yeah, I can multiply by the lattice scale factor, can't I? Divided by mag. Yeah, I can multiply by the lattice scale factor. And then I don't need to do this here. Right? No, I don't. Sine h scale times dist plus scale. Divided by scale. And that's going to get you, yeah, okay. No, I think I still do need to do that. This is so fucking confusing, dude. I have no idea what's going on. Okay. What? Alright, what's the issue? Oh, right. I want to run server release, yeah. It's just so much faster. Oof. 74 milliseconds. Okay, I think... yeah, I don't know. I don't know, man. 0.5? Obviously, that's not like a real solution. No. Oh my god. Why is it so insanely slow? 0.1? Yeah, why is it so slow? That's crazy. I guess maybe this number is just like... most likely my math is just wrong. Most likely. Well, for one, this should be the absolute value. Right? I mean, that's like, that's kind of a no-brainer. Oh, you know what? Yeah, now I think about it, no, I don't need to do that, do I? Because if I look at well, not, yeah. Yeah, if I look at retract sample, then that is if I look at retract sample, that's going to be yeah, I guess I should just think about it like this, right? Time scale, a sign. Yeah, that's going to be multiplied by the distance anyway. I wonder if I can get rid of this. I mean, the more I think about it, the more I'm like, well... Oh. Wait, yeah. Well... Yeah, I just realized this should not be disk. This should be sparse lattice space, right? Yes. Should be sparse lattice space. But then if I stop doing that, then... Okay, that's nice and full. Yeah, we still get balding on the sides of the mountains. Like, did it do anything? I genuinely would not be able to tell you. What if I multiply that by 10 as well? Jesus Christ. Oh my god. We're getting into 3 frames a second. Okay, so not 10. Why not 10? Yeah, wait, why not? Why not? 2? I mean, 1 didn't do anything. Right, that seemed like it helped the balding issue. Doing 2. Now it seems like part of the issue is that the... Yeah, there's no horizontal like this is really full, but it's only because it's like a fucking 1,000 triangles being overdrawn. There's no horizontal component at all. Am I crazy? Or there's no vertical component at all? Like, yeah, here's the original one. There's a vertical component. And that one, there's no vertical component. Now look at that, yeah. It's like a ton of triangles, and they're all super jumbled up. And they're very obviously at radically different angles. Yeah, I mean, we'll see how it performs on lower end hardware, but, you know, that's like good. That's good. Now I go over here, and what I see is what if this needs to take into account... Actually, you know what? What if they're all planar bounds? What happens? I mean, it's insane. Yeah, it's definitely fuller. It's definitely fuller. Why is that so intense? Yeah. Yeah, you can tell that it's not as full on those mountains. I wonder... Yeah, man. There's definitely something to that. I don't know. Yeah, when you're at a grazing angle. Yeah, I think that's probably the issue, is that the planar bounds is more correct, but well, I don't know. Yeah, I need to optimize my maze rendering. It's just, I think I have a few ideas. Just like, that's so painful. Yeah, well, my first idea, which is pretty simple. First idea is oh. Oh yeah, okay. Oh, yeah. That's how I can bias it, actually. Yeah, if I go to Maze Shader, so the further away from the thing it is, the more likely it is to be so the length, right? Let's just do like 1,000. Yeah, 1,000. And then alright, let's say this D is greater than dense radius. What the fuck? Whoa. Whoa. What in the what? What the dude, what the fuck? Oh, yeah, okay. It's because I'm biasing the thing. That's trippy as shit, dude. Holy fuck. have never thought it would create that kind of artifact. Yeah, it doesn't fix it because it's... Oh, yeah, it's an issue with the grazing angles. Yeah, we need more verticality, is really what it comes down to. Yeah, okay, so that's not gonna fix it. Yeah, I mean, it really is. We just need more verticality. Hmm. It's the vertex shader, and it's the Y component. Oh no. Okay. Oh fuck. Okay. Jesus Christ. Um. Okay. Yikes. You know what? What if I lower the vertices like substantially? I know that'll destroy like my everything, but the mountains look so ugly now. Oh my god. I guess they don't look that bad. Yeah, I guess it's just way too much overdraw. Which is sad. Well, I guess I'll be working on this one tomorrow. So, yeah. Anyway, goodbye.